So looking ahead next 5 to 7 years,
What do you think will be the biggest development in spatial computing?
what do you see is the future of GIS and spatial computing?
Where do you think this field is going? What do you think will be the biggest development in spatial computing?
What do you think is the future of spatial computing?
I think the most interesting thing in spatial computing is that there's no one thing that's future direction. If it's just one thing, it will be very narrow field. But now it becomes kind of an ecosystem. So what I always see here, there's new stuff if you want to do applications. There's a lot of people in geography and GIS domain do a lot of applications on geographic data and the analysis of this. That's a huge thing. However, you can go lower in the stack. Lower in the stack, even very low in the stack, like what we went for map reduced environment, supporting big spatial data. In between these two, there's a huge thing is there, visualization, even just kind of the managing vehicle-to-vehicle networks. There are many things here. So it's kind of an ecosystem thing, not to define one thing.
Wonderful.
And that, I think, the difference between spatial computing now and spatial computing 10 or 15 years ago. 10 or 15 years ago, there were very few people actually addressing different issues other than applications. Now it's more of an ecosystem thing.
I think when I think about it in a very generic way, I think to go more on to kind of like expand more on this changing graph paradigm. People are collecting data everywhere, and if you use an online navigation system, everybody's saying that, okay, fine, don't take this road because it's congested, and this is the travel time, and so and big companies like Nokia is putting data out there, so there is a lot of data coming in, and so we need to somehow incorporate this into our computations to make computations more meaningful. So I think we need to have a mechanism to somehow use this data meaningfully, but at the same time, the volume is growing so drastically. So we need to somehow make the computations efficient. So I think big data is here, so that I think that is going to sort of creep in everywhere. So we need to explore that and how we can actually incorporate the big data analytics into network computation, which is not that easy because networks are not that easily partitioned, sensibly. So we need to figure out how to partition networks sensibly so that we don't have too much communication going on between the nodes. And also we don't sacrifice too much of accuracy. Mining is a different issue because I think mining, as long as we find out the trends, it's okay. But with networks, I know it's still a tough problem how to do that. So, and then also we need to adapt our algorithms also to suit this big data paradigm. We need to figure out how to do that. And even if we don't move into that, as the volume of the data increases, it is basically, and also even just bringing in time kind of complicated everything.
You explode the data volume, right? For each instant, you may have a replication of the network, right?
Yeah. And so it is basically, and also we cannot apply the old algorithm techniques. Most of the assumptions that we made with respect to the old algorithm design cannot be applied when time comes in because most of the properties that we relied on to apply these techniques are breaking. And for example, I cannot use dynamic program to find the best shortest path, or rather to answer the question when to start.
Oh, wow. So we did talk about Dijkstra and A stars. So, so what happens to those when you add time?
Because Dijkstra basically depends on a property called greedy property, and which actually depends on a suboptimal structure, of the final solution, which breaks when we actually extend the shortest path question to when is the best time to start so that I spend the least time on the road. So we are actually talking about optimizing it across on the graph and across time too. So when that comes in, the greedy property is not satisfied anymore. So I cannot extend Dijkstra easily.
That's a really tough question. I guess there's a few things that I think will be really important. And I think again, I'm going to focus more on the widespread adoption of certain technologies. So again, for a long time, people have been talking about the Internet of Things. things that are computationally, objects in the real world that are computationally, they're hooked into the computational world. They have maybe active transmitters or passive sensors so that we know their location. I mean, the obvious example, people lose their keys, they forget where objects are, up to inventory management where you want to know what objects exist or what objects you have in stock, what objects you don't. And even in your refrigerator, you want to know what you're out of, what you need to get. Again, ideas that have been around. The technology there exists in some prototype forms, and in some places it's being deployed, but it's not widespread. I think that's going to be a huge thing. I think another humble thing is battery power. You know, we all have our phones, but location sensing technology drains batteries.
Certainly does.
And charging batteries is a huge problem, and there's talk about batteries that are going to last days instead of hours. I think this is going to make a big difference as we want to hook all the world into the computational world, the physical world into the computational world, including knowing locations of things. And I think that's going to be really important. We need better battery technology and processors that draw less power. And then I think the thing that I don't quite know how we're going to do this, but as we do that, the privacy challenges are going to become massively greater, even than they are today, when the whole world is aware, the whole physical world is part of the computational infrastructure. The world knows where you are and what you've been in proximity to and who you've been in proximity to. There's going to be a chance for great services, but how are we going to avoid ubiquitous nagging, ubiquitous advertisements, and ubiquitous surveillance, and yet still get benefits from it? So I think as we move forward, the opportunity from just widespread, computational awareness of objects is going to be great, and yet the challenges that poses are going to have to be addressed through a combination of, technical and social and policy innovations as we move forward.
I think my specialty is the GIS, and especially the algorithms and the joins and the. But my group is the learning to data mining algorithms.
Okay.
So the first 3 years we do some modeling and the algorithms about the spatial joins.
Okay.
Then next 3 years we will spend most of the time on data mining tools and development.
They are wonderful. Wonderful. You mentioned exposome, and what is that, and what is its future?
Exposome is a study of the effect of environmental factors on human health.
Okay.
So it could be a very short time period. For example, asthma. Patient exposed to a certain like a smoke, cigarette smoke, and they got attack.
Yeah.
Or exposure could be like a very long life period, which is cancer.
Right.
So different time intervals of patients monitoring are required. And the exposure, the world is just started in 2006.
Okay.
So it's quite new field.
Okay.
And there is a lot of problems of measurement and the modeling and algorithms.
They are wonderful. And one last question. Most of us are used to having GPS on smartphones and the cars and so on. But your group and your neighbor in Asthma Polis, they were putting GPS on inhalers used by asthma patients.
Right.
So do you see more use of GPS with sensors to monitor personal health and environmental health in the coming years?
Right. So asthma patients are recommended to carry inhalers.
Right.
And also they use the peak flow level gauge every day. Those two are the main equipment for those patients need to carry.
Right.
And so we developed sensors that is very tiny microprocessor that is built in an inhaler. This is a kind of inhaler the US and UAE patients use.
Right.
So we developed a small cap
Right.
that actually come with this inhaler.
Okay.
Whenever the patient pushes the inhaler button, we measure the time and location.
Oh, okay.
and also how long it actually pressed,
Right.
so that doctors know whether or not this the patient is properly used inhaler as well.
Okay.
So it can be used to the analysis of the location and time, exposure time. At the same time, it can be used for the patient's training.
There. Okay. Wonderful.
And this data is going to be transferred to users, the patient's mobile phone.
Okay.
And then we store this one in a secure server, so therefore the data analysis later.
They are wonderful. So personal health may be a big area for spatial computing
Right.
as we
not
move
only
forward.
yeah, and we call this as the individual health care.
Care. Okay.
So most of the doctors in the current research in medical field, they use the average of this, some of the symptoms, average of their temperature and so on. But more likely people, their reaction, their symptoms could vary based on the individual symptoms. So this is what we want to do, provide the individual care of their health system.
So let me just mention two, because I think there are a lot of them, but I think two would be a good start. First, this idea of engaging the citizen with geographic information. I mentioned that it's having profound effects, and I think those effects have still to play themselves out. And when we talk about VGI, we usually think of a project like OpenStreetMap, where people are helping to create a map of the world by using their own GPS or their own cell phone or what have you. But that's using people to produce something that has been traditionally part of our lives. And what is really different is when you say, what are people really good at? What kinds of geographic information do they really harbor in their heads? And it's not information about latitude and longitude. It's information about places. And so I'm trying to explore the whole possibility of developing technology not around coordinates and around space, but around named places, features on the Earth's surface. People have huge repositories of information about places. Now, you know that Seattle is known as a rainy place.
Right.
That piece of knowledge doesn't fit within any GIS.
Right.
And yet that sort of knowledge is enormously valuable, and we have huge resources of that knowledge in the human mind. So I'm interested in exploring how we can release that knowledge and share it.
They are wonderful.
So that's one.
Great.
The second one is that we sometimes refer to GIS technology as the 83%,
I see.
the 17, go the other way, the 17% technology.
Right.
Because the average human spends only 17% of their lives outdoors and 83% of their lives indoors. And so I'm very interested in the possibility of an indoor version of GIS.
Great.
As GIS helps you navigate outdoors, I think it should also help us navigate indoors.
Wonderful.
Believe it or not, there are actually people in this world who get lost in their own homes. All of us get lost in large shopping centers, in complex airports, and yet our GIS technology doesn't work there and doesn't give us very effective help.
Wonderful.
So I think one very definite growth direction is indoor GIS, geared towards the 83% of our time that we spend indoors, rather than the 17% we spend outdoors.
It was always hard to predict, and 2 to 5 years is not very long. So I would not expect like dramatic changes in the next 2 to 5 years, maybe in 10 to 15 years, but not in 2 to 5 years. I would assume, though, that we will end up with, from a mobile computing perspective, with much more useful apps. In terms of, if you look at some of the problems that we're facing now with, you name them, climate change, energy, resources, I think there is a potential to use a lot of apps and sensors in order to steer people towards better behavior. So I'm thinking of, for example, an app that tracks your behavior in terms of energy efficiency and provides recommendations how you can do better, or how your energy behavior compares to other people, like going a little bit into the geo gaming area, that where many things I think can be improved and will improve. So this is what I would expect for the years to come, for the next couple of years to come.
So then you actually anticipated my next question. What do you think about the next 10 to 15 years? You know, when you're an old man and I'm middle-aged.
Well, I'll still consider myself middle-aged then. So we'll both be middle-aged men. 10 to 15 years. Well, I'm giving you some ideas from my research perspective, of course, but having been working with all these mobile eye tracking and new interaction devices and Google Glass and stuff like that, I think in the next 10 to 15 years, I'm pretty sure that we can expect some brand new interaction modes. So, I mean, if I had the forecast, I would say that more and more people will be using, maybe not Google Glass, but, you know, similar devices. And I personally think at that time, every mobile phone will have an eye tracker integrated. So you can actually use your eyes to, you know, do simple things like click on buttons and stuff like that. But also that the system actually will record your gaze patterns, and based on the gaze patterns, extract or get some information about what you want to do with the device, and maybe be supportive in supporting you during the spatial temporal tasks that you're doing. So I think more interaction, more activity recognition from the system based on, you know, new technology such as eye trackers, which nowadays are not really, I mean, not even with Google Glass, you have an eye tracker integrated, but I think that's a very useful interaction mode. And of course, other modes will improve too, like, you know, audio communication. I mean, people are already working on hands-free navigation systems, and I'm pretty sure we'll have most of that stuff ready in 10 to 15 years.
The one that I kind of see popping up is sort of these analytics that are tailored towards very specific domains. And an example would be taking traditional analytics techniques such as hotspots and tailoring them to, say, road networks or to arbitrary shapes, rings, polygons, different types of things like that that suit particular domains. So this is sort of another angle that I see is coming in the future.
It's really hard to predict, but you know, if we take Google Earth, right, and now we have tons of basic geoinformation available. Of course, you know, this information needs to be up to date. I think you know, this is a challenge because, you know, the data we need to handle and the data sets are getting more and more complex over time. And with that challenge, we add more and more extra or so-called meta information to that data. And of course, same there, you know, with the meta information, we need to, you know, we need to keep that data sets up to date, right? We don't really, we want to know, okay, here's the supermarket. But of course, we also want to know, okay, here, you know, these are the opening hours, that's the URL. And these needs to be really updated all the time. So all the meta information needs to be updated constantly, and it also needs to be coherent with other information. So the relationships between the data sets, between the meta information, the semantics, they also need to be worked out well. I think this is a very, very challenging project that will keep us busy in the next 2 to 5 years. With that, I think, you know, this is like behind the screen. But with that, because we add more and more information, it's also, you know, challenging how to adapt the interfaces to allow people to explore all this additional meta information that is beyond the pure spatial information. So we have just seen the massive, or like it was a major redesign of Google Maps. And with pros and cons, I guess it will also be discussed in the course. But, you know, it's not just that we need to keep that information updated. We also need to adapt the UI, the user interface, and allow people to explore, you know, the benefits of the extra information. I think that's, you know, maybe the challenges for 2 to 5 years. Then, you know, 10 to 15 years, very, very hard to predict. But this is what I learned in my first lesson at the university. I heard the phrase that 80% of all decisions in politics and economy have a spatial component, and I think it will increase. So the importance of spatial information for a variety of disciplines and a variety of decisions will increase. And I guess we will notice that like in 10, 15 years, so that a lot of things are based on spatial data. But it's hard to really predict what will go on, what will go on in 10, 15 years.
For Minnesota, again, it's expanding to, I think, all disciplines on campus. We're certainly growing in some of the big data needs and those types of projects, but it's mostly other disciplines picking it up and working collaboratively between multiple departments.
Okay, wonderful. So, I have an interesting analogy. When I was in undergraduate school or earlier, many campuses had a computer center, which was a shared resource. People who wanted to use big computing would come there for help. And then it slowly grew into a graduate program and then departments, and now it's a very, very vibrant discipline with large industry.
Yeah.
Do you see similar analogy with GIS service centers? Do you see this precursor to becoming, bigger things on campus?
I do. I think it will. I think that there's the idea of this spatial university where you integrate GIS, remote sensing, throughout much of the university, and it will continue to grow. And in a way, we make use of a lot of other resources, such as the supercomputing center and other resources to do that.
If you look at all the major problems facing the society, food security, water security, energy, they all involve solutions that would require big role being played by the spatial computing, because most of these problems involve data that are spatial in nature. That goes with agriculture, with food, with water, with energy, and being able to understand these data sets and how they interplay, what is the interplay between food, water, and energy. You really need to involve spatial computing technologies to be able to answer this. So I expect spatial computing to play a major role in advancing the major interests of the society as we go forward.
Yeah, wonderful. But is it just an application of well-known computer science technique? Could you just take your classical data mining technique and run those on spatial data? Will that do the job, or do you need new computer science here?
New computer science here. That's a very good question, and I often tell when I show what we're working on to the audience, to the students, and I often remind them that here is a problem. If you use standard textbook techniques, how far you can take these problems, and what you need in addition to go beyond. And I'll give you an example of something we just talked about earlier, which was the detection of fires. And you saw that we are able to sort of identify locations of fires on the globe. We're able to identify locations of insect damage on the globe using the analysis. Now, if you try to work on these problems using traditional techniques, you face a number of challenges. These data sets happen to be, the events that you're looking for happen to be extremely rare. To the extent that most locations, thankfully, do not burn all the time. They burn very rarely. The other problem is that you do not have ground truth for most of these. In California, they track fires very carefully. But if you're looking at Siberian forest, there's hardly any ground truth there. So if you want to do a global coverage of what these events are, you have to build models that can work in absence of ground truth. They can work with highly skewed data sets. They can take advantage of the spatial nature of the data and the temporal nature of the phenomena. And most of the classical techniques that we discuss in our books and data mining courses do not incorporate for these special needs. So there's a tremendous need for novel techniques to be developed in the area of spatial computing.